Hey gang, Mr. Cruze here with another lesson for you. If you're watching this, I am clearly not at school, or if I am, I'm in extreme amount of pain, and you can just watch this video to have me teach it. So thanks, past me. Anyway, I'm going to introduce you today to hypothesis testing. I'm going to try and move through this as quickly as possible. Obviously, if you have questions, hang on to them, and I'll be glad to answer them another day. So basically, our job here now is to try and make conclusions about populations, okay? We are trying to make claims about the entire population. Sometimes that population can be the entire world, sometimes it could be an entire country, it could be this classroom, whatever. But obviously, I may not be able to get data about populations easy, okay? So I might have to use samples. And there are two ways to go about making statistical conclusions. We can estimate population parameters, okay? That's called confidence intervals, and we're not going to do much of that in this class at all. And hypothesis testing. This is the one we're going to focus on the most, okay, for the rest of the semester. It's one of the most important tools and applications to real-life problems. You've seen these probably before, you just didn't recognize it, okay? To start off with, though, you have to start with a hypothesis, and a hypothesis is simply a statement or claim, okay, a statement or claim about a population parameter, okay? Now, yesterday we did the activity where the population parameter was 0.5, right? But sometimes the population parameter can be a mean. So often the mean, you'll see us use mean a lot. And it's developed for the purpose of testing. Okay. Maybe I believe the mean of our next test is going to be 75. Okay, so maybe I collect some data and I look to see if my hypothesis is correct, okay? And there's going to be a 5-step procedure, and the cool thing is these are the same 5 steps that we will use for the rest of the semester. Your first step is going to be to state the null and alternative hypothesis. More about these individual steps here in a second. But we're going to start off by stating the null and the alternate hypothesis. Then we're going to state the level of significance, okay? At what point do we finally decide to reject our null hypothesis and say our alternate is correct? We're going to identify the test statistic, okay? That'll basically tell us what test we're using. We're going to formulate a decision rule. When do we reject, when do we not? And then we're going to make a decision. We're going to use math and make a decision, okay? And I'm going to walk you through more of the finer points of these 5 steps. So step 1, state the null hypothesis and the alternate hypothesis. So the null hypothesis is simply a statement. It's a statement about the population parameter in question. Okay, a statement about the parameter in question. Yesterday it would have been that p equaled 0.5, right? That was our guess for the probability of success. We denote the null hypothesis by this symbol, HO, okay? That's actually read H naught, okay? Or H sub 0, however you want to look at it, but it's denoted by HO, okay? And it should always contain the statement of equality, okay? AKA, it should have equal signs, okay? So the statement of equality should have the equal signs. So P equals 0.5, okay? It'll never have an inequality. The null hypothesis will never have an inequality. And your conclusion is basically all about the null hypothesis. So your conclusion at the very end of these things will be either to reject the null, okay, either to reject the null or fail to reject the null, okay? We will never accept the null hypothesis. We can never prove the null hypothesis is true, same as you can never prove somebody innocent. Either they are guilty, reject the null, or they're not guilty, fail to reject the null. Okay, that's basically what we're looking for. The alternate hypothesis is a statement that differs from the null hypothesis. Okay, a statement that differs from the null hypothesis. Okay, so it is denoted, okay, by, there's a couple things here. I usually use HA. But you can also use H1. Mrs. Crimer might use H1, so you'll kind of have to, just be aware depending on who you have. I will probably most likely use HA, okay? And this one should always contain the statement of inequality, okay? It will always contain the statement of inequality. That means it will always have a less than symbol, a greater than symbol, or a not equal to symbol. Okay? And then we're going to assume that the alternate must be true for the most part if your conclusion is to reject the null. Okay? If you decide to reject the null, you're basically saying that you have evidence that the alternate is true. Okay? Now, might not necessarily be true, and that's where we get into types of error. There are type 1 errors and there are type 2 errors. A type 1 error is what happens if you reject the null when it is actually true. Okay? A type 1 error is if you reject the null when it's actually true. This is also called a false positive. You may have heard this term before. I usually use the example of telling someone they're pregnant when they're actually not. That is a type 1 error. A type 2 error is the opposite. If you fail to reject the null when it is actually false. Okay? If you fail to reject the null when it's actually false, this is called a false negative. Okay? This will be basically telling someone that they're not pregnant when they're actually pregnant. Okay? So type 1 and type 2 errors. All right? And again, you can use these notes, so you don't have to worry too much about memorizing all of this. Okay. That's all step 1. So step 2 is state the level of significance. The level of significance is the probability, so it's actually a probability, with which we are willing to allow or willing to risk a type 1 error. Okay. It is denoted by this little fish-looking symbol. This is the Greek letter alpha. Okay? Denoted by alpha. And for this class, this may not always be true, but this will usually be given in the problem. Okay? We will usually give you alpha in the problem. Okay? If not, we will default to using alpha of 0.05, aka 5% level of significance. Okay, and more about what this alpha stuff means as we go further into this. But basically, if we get an alpha less than 0.05, that's a small probability, which means we have evidence for against the null. Okay, step 3 is identify the test statistic. So what is a test statistic? It is a value computed from sample information. And I apologize if I'm going too fast through this. You can obviously pause it and rewind it and all that stuff. Which is then compared to the parameter in the null hypothesis. Okay? So we're going to be using this number to compare it. Now, in step 3, you're just basically telling us which test to use. And there's 4 of them we're going to do. And this is basically how we do it here at Greenwood. If n is greater than or equal to 30, we're going to use a z-test. Okay? If n is less than 30, we're going to use a t-test. Okay? If we are comparing more than 2 samples or populations, okay, so more than 2, we can't use Z anymore or T. We have to use F. We have to use an F test. And if we are testing relationships between variables, like height and shoe size, or I'm sorry, not height and shoe size, like eye color and hair color, we're going to use chi-square. Okay? Now, more about those individual tests over the next couple of months, okay? But this just kind of gives you an idea of what we're going to be using. Step 4, we're going to formulate a decision rule, okay? Basically, a decision rule states the conditions when the null hypothesis is to be rejected. Okay? When the null hypothesis is to be rejected. You know, what are we looking for? At what point will we decide that we're going to reject the null. And it will look something like this. Reject the null if P is less than blah, blah, blah. Okay? Critical region, it's simply the area or the place of rejection. You might recall back when we did z-curves that we had cutoff boundary values and we shaded above or below certain numbers. Very similar idea with critical region. And the critical value is the boundary for the critical region. Okay? We're going to mostly be focusing on p-values, but this stuff does come up. Okay? If the alternate hypothesis contains the less than symbol, then the critical region is located on the left side of the graph. Okay? Is located on the left side. That makes sense because it's less than to the left. If it's greater than, then, surprise, surprise, the critical region is located on the right side. And if it's not equal to, then the critical regions are located on both sides. The critical regions are on both sides of the graph. And again, this will make so much more sense once we actually start doing some of these problems. Right now, we're just trying to get the ideas and the vocabulary down. And then step 5, this is probably the one that has the most work to it. Step 5, you're going to do the following things. You're going to first compute the test statistic. Whether it's z, t, f, or chi-square, you're going to compute it here in step 5. Then you're going to find what is known as a p-value associated with the statistic. It's basically a probability value. Okay? And then, based on that, we're going to decide whether to reject the null. Do we have enough evidence to reject the null? Or do we fail to reject the null? We don't have enough evidence to say that they're guilty. And then we're going to write out our conclusion in context. Okay? Write out our conclusion in context. Don't just tell me reject the null. Okay? Tell me reject the null, and we do have enough evidence to say that something is different. Okay? Whatever the question's about. Now, what is a p-value? A p-value is the smallest level of significance. The smallest level of significance for which the observed sample statistic tells us to reject the null. Tells us to reject the null. Okay? It is also the probability, this is a special definition from me, the probability of getting our result or farther if the null is true by random chance alone. That probability we found today with the coin flipping and the dolphin activity, okay, that was a p-value. For a left-tailed test, this kind of matches up with the critical region area. P is the area in the left tail. Okay, if it's less than, it's the area in the left. If it's a right-tailed test, it's the area in the right tail. And if it's two-tailed, aka not equal to, the probability the p-value equals 2 times the area in one tail. Okay? And the lower the p-value, the more evidence there is in favor of rejecting the null. Okay? Essentially, you can use this. This will kind of help you. If p is less than or equal to alpha, reject the null. If p is greater than alpha, fail to reject the null. That's kind of what we're going to be using. Okay? I know this is a lot. I know it's a lot of vocabulary, and I wish I was there to explain it a little more in detail for you. But just get this written down. You don't have any homework for tonight, so please work on something else. And that is all I have for you for now. So until the next time, have a good one, guys.